Alright, so today is lesson 3.5, rates and unit rates. I wanted to say ratios. Rates and unit rates. I think I wrote ratios up there, right? Yeah. I knew I saw ratios somewhere. Rates and unit rates. Alright, so here's what's going to happen today. We're going to look at 3.5. We finished lesson 1 through 4. We only have 2 lessons left. The goal is today we finish lesson 3.5. Next week on Monday, because we don't have school Wednesday because of Thanksgiving break. Next week on Monday, when you guys come in, we're going to introduce 3.6. We'll do a little bit of review of 3.5. We'll introduce 3.6. And then I believe on Wednesday we'll finish up 3.6. Friday we'll do a quiz. Okay? So you're already going to have another quiz coming up. This quiz I think you'll enjoy though. We have kind of a different approach to it on this one. Alright, so lesson 3.5, rates and unit rates. Our goal today says, I understand the concept of a unit rate and solve rate problems. I like this lesson a lot, and actually I feel like this one's kind of fun, what you guys are going to do today, as long as you stay in control. Because this is one that we really apply. I literally use this all the time. Anytime I go shopping, I use this. When I'm driving, I'm technically using it. If you want to be a better consumer or shopper, you will use this. A few students have said that they're even going to be able to help their parents when they go shopping make better choices. So, let's get right into it. It says, on your notes, sorry, forgot to fill this part out. You should always put, just like your homework paper. I'm starting to tell people I'm so disgusted that as 6th graders, we don't know how to label our papers, and then I'm getting people's assignments mixed up, and they're making things difficult. So, here's the new thing. Top of your paper, same rule, you need to have these on, but now I'm going to have to hold you more accountable for it. You need to have these 4 on your homework paper. Your name. Today's date is the 25th. Yeah. Assignments, lesson 3.5. Class period, first block, silver. Now, if you do not have yours on yours, don't worry about it. I'll figure it out for you. I'll be your little secretary. However, I charge for my services. So if you do not put your heading on your work paper anymore, you turn it in, I'll fix it for you. I'll do it for you. But then I'm going to charge you 3 links plus for it. So, if you go ahead and just get a blank piece of paper and you do this when you turn in your work, we're all good. I don't have to do anything. But if you need me to do it for you, I will do it for you. I have no problem doing it. But I need to be compensated for my time. So, warm up. Alright, so Zeta and Grace are the only ones, so they're going to lead us on this. Grace, how did you find the first blank? It says find the missing values. How did you find this one?
On the bottom row for short,
Uh-huh.
I saw that 5 times 3 is 15.
Okay.
And so on the top row, I did 3 times 3.
Which is 9. Okay, perfect. Zeta, the next blank. We didn't know how many, when we have 15 shirts, we don't know how many shorts we have. How'd you find it?
For 3 times, I did 3 times 5 for 15. And then I did the same for the bottom, and then 5 times 5, which is 20.
Perfect. They then asked us to write out the ratios. What would be our equivalent ratios? There's 3 of them. What would be one of my ratios from this table? Zeta?
3 and 5.
So we'd have 3 to 5. Sai? 9 and 15. And our last one, Grace. Whoops. And I'm going to add one thing into this. If you're putting this notes, if you wrote these down, I'm going to go ahead and write down what the coordinate points were too, because we had to get that when we graphed. Remember, that'd just be 3, 5, 9, 15. What is that noise?
Yeah, somebody's
In a locker or what? Is it out here?
Yeah, it's not nice. I think
It's in one of the lockers. I might ask the custodian to come open it and then we'll shut it off or something. Alright, so yeah, that's fine. Alright, so remember, when you looked at coordinate points, remember your first coordinate is your x coordinate, your x-axis that goes left and right. Your second coordinate tells you up and down. I did see some people make those mistakes with their graph. They flipped it too. Well, that changes everything. So make sure you do that right. Alright, key idea. A rate is a ratio of two quantities using different units. So when I say we're going to talk about a rate, I'm talking about two quantities using different units. You solved various ratio problems in previous sections that involved rates. Now you'll use unit rates to solve rate problems. All that means is we've been using ratios and rates all this time. You guys have been learning the math behind it. Now we're going to learn how to apply it. A unit rate compares a quantity to one unit, I'd underline that, of another quantity. When I ask you for a unit rate, we want to break it down so it's something compared to 1. Before we've seen 3 to 2, 10 to 20, 7 to 5. Well, those are all fine. Those are ratios. A unit rate was, we want to make that second unit only 1. We're going to compare it to 1. Equivalent rates have the same unit rate. Mainly, they're saying if I have a unit rate of 2 to 1, an equivalent rate would be like 4 to 2 or 3. I don't want to do 3 because that might be a fraction. 8 to 4. Okay, these are equivalent rates because if I simplify them, they all come down to 2 to 1. 1 is that unit rate. So 2 to 1 is my unit rate. Here's an example. I paid $27 for 3 pizzas. So my ratio was 27 to 3. Well, if I go ahead and I simplify that, just like if it was a fraction, 27 over 3, and I go ahead and I simplify this, I could divide each side by 3, and I'd get 9 over 1. This is my unit rate. $9 for 1 pizza. Now, an important thing I'm going to put up on the board is when we write our ratio, I'll do that in just a second. Oh. We want to make sure that whatever unit we're going to is second. And you're going to see that in this example. So, for example, on my way to school today, brought Prairie View over, take a turn on Clan, go through that neighborhood, and I went by a sign. I thought it was going to be a boring morning. I was kind of like, oh, going to be a boring day. But then I saw a sign, this white sign with black numbers on it, and 2 numbers said 25. I was like, whoa, if I hit a kid, it's worth 25 points today. So I tried to hit a girl that was crossing the street. Some boy he was over on the bus stop. I popped him. I was like, yeah. He dove out of the way. I got no points today. Deputy Webster saw me. He pulled me over. He was like, what are you doing? I was like, 25 points, dude. I almost got someone. And he was like, you're an idiot. I was like, oh, okay. What does a 25-point sign actually mean? Does anyone know what sign, when you go through and there's a big white sign that says 25 in the neighborhoods, what's that sign talking about? Because apparently, according to the law, it's not hitting a kid. I think maybe they should make that more clear.
Yeah.
Joseph?
It's the speed limit.
Okay, what do you mean? What's 25 stand for?
The miles per hour.
Okay, so it stands for miles per hour. So I'm going to look at that. So the speed limit really said 25 miles per hour. This is our real rate and ratio. What is 25? What does miles per hour mean? Shay?
How many miles you should be going for every hour that you're driving?
Good. If I was driving 25 miles per hour, some people don't even realize this. This is what happens in a car. If my speed and I go to the speedometer, it goes to 25. Like, I don't think my boys even understand this because they're too young. But it goes to 25. That means if I drove that constant speed for 1 hour, I didn't speed up and I didn't slow down, in 1 hour, I would have driven 25 miles. This is our rate. Per can tell us that we're doing a ratio. And when I say per and I have just hour, that means 1 hour. We just wrote a unit rate. 25 to 1. 25 miles per hour. So, it was the weekend. It's Sunday. I decided to go cruising with my grandma because it would be awesome. We got in her car. Okay, this ain't true because my grandma's in Nebraska and she hasn't driven in the last 50 years. But let's pretend. So grandma and I were like, hey, it's a Sunday night. Let's hit the streets. So we get in her car. And she starts driving. She turns that radio all the way up because she can't hear it. So we have it blasting. She's like, oh, this stuff's stupid. Turns on her jazz music, which is amazing. And no, it's not. And we had to listen to her jazz music song about 5 times because every time she forgot that we just heard it. And when it restarts, she's like, oh my God, I love this song. Your grandpa and I dance to it all the time. I'm like, we've listened to it 5 times. What's that? So anyways, Grandma and I are just cruising. And she don't break for no. That 25 points, if a kid gets in front of her car, boom! She's like, what was that? So, she set her cruise on 25. We're going 25 miles an hour down I-29. So, everyone else is like, did I ever tell you about how I invented butter? Anyway, so we're cruising 25 miles an hour down I-29. People are just, and we're listening to that same jazz song. And we did this for 3 straight hours. After 3 hours of our cruise set on 25, listening to the same song, who can figure out for me without shouting it out? How far did we go? How far did we go after 3 hours? Let's see if I can get this. This is what we listened to the whole time. Every now and then she swore about it, right? So in 3 hours, how far did Grams take me? Sai?
75 miles.
I don't believe you.
Well, so,
Felt like a longer place than that.
well, of course, because you're not going the speed limit. But,
How'd you get 75?
I got 75 because 25 is for 1 hour.
Okay.
And you guys drove for 3 hours. So 25 times 3 is 75.
Awesome. And that's exactly what we want to do. We could set this up a number of ways. You guys have learned how we could set up a ratio table. We could do that. I could set up underneath. I said I want to go 3. I want to know how many miles per hour. I went 3 hours. 1 to 3, we times by 3. So I do 25 times 3 is 75 miles per hour. Okay? This is what we are going to work on today, except we're going to go the opposite way. Because when I went with my mom's the exact opposite of my grandma. She has a little bit of her dad, my grandpa, in him where the foot's just heavy, if you know what I mean. So, with Mom had to meet me because Grandma got lost. After 3 hours, we ended up somewhere else. And then Mom got in the car, and we drove somewhere for 3 hours. Now, when Mom and I drove for 3 hours, woo, And we went 327 miles.
Wow.
And we did
Oh,
that.
I thought you meant miles per hour.
We went 327 miles in 3 hours. Talk with your table group. Who can find out how fast did my mom drive? Don't shout the answer. Do not shout the answer out. Which group can figure out how fast did my mom drive?
About 100.
3 hours. 180.
You know the answer?
27.
No? Alright, so, real quick pause. This is going to be for a dum-dum sucker. If I call on you and you know the answer, I'll give it to you. If I call on you and you tell me the truth, you did not know how to find the answer, but someone told you, and then you get the answer right. So like Shar doesn't know how to get it, but Caleb told it to her, and she can tell me, I'll give her a sucker and Caleb. So if you share with someone and they get picked, you can earn a sucker too. Okay, about 30 more seconds. How fast did mom drive?
I think that would be 100.
Okay, one person from your group go get number 1 basket, someone go get number 2, someone go get 3's basket, someone get 4's basket, and someone get 5's basket. Alright, let's see what we have. Joseph, good looking or smart one? Smart one, okay. Smart Joseph. Did you know the answer? Did someone help you with it? Okay, who helped you? Alright, let's see if Anna helped smart Joseph.
Okay, so
Oh, but Anna doesn't see the answer. Joseph has to see. We have to test whether you taught him well. So Joseph, what did you get for the answer? And how did you get 100? She drove 109 miles an hour. And she's like, man, yeah, learn her. Move over. Here comes Christine. All right, how'd you get 109?
So I divided 327 divided by 3.
Good. Now, there's a couple ways we're going to look at this. 1, I could set this ratio up just so I say 1, because I want to know miles per hour. I want to know 1 hour. So I could say I did 3 divided by 3. So I have to do this divided by 3, which does give me 109. My question for you was, how many miles per hour? Now the cool thing is, if I ask you that, you actually don't even have to write a ratio, because we know the other ratio is 1. We just know the first term. And since I asked miles per hour, you're going to do your miles. This is where this comes in play. Listen to your ratio, because people would divide it backwards. I had this happen last week. If I want to know which way to set this up, where's my calculator? Alright. So, in my unit rate, I said I want to know miles per hour. I will type miles first. Ooh, I erased something. 327 per hour. And I'm going to divide 327 by how many hours I went. 3. And I get 109. Alright, so here's what I want you to do real quick. I'm going to give you about 60 seconds. I need you to turn and talk with your table group. When do we have real life ratios? When do I really need, not just ratios? Because you could say, oh, there's 15 boys and 12 girls, ratio of 15 to 12. Okay, that is true. But when do I use unit rates? When may I ever need to find out what a unit rate is? Turn, talk to the neighbors. Go. What do we come up with? When might I use a unit rate in real life? Siri? You're totally correct. Sometimes when I'm measuring something,
how many slices of bread and a certain amount of rice?
maybe. Huh? In cooking, we could use it. Actually, I like Siri. I didn't even think about this one, but when people are building houses or even buying a house or selling a house, they don't just randomly guess the price and stuff. They usually make it fit in the market and all this stuff. But one thing, like if you've ever watched these house hunter shows and everything, one thing they'll say is, oh, the cost is so many dollars per square foot of the house. Just because my house is located in a certain area doesn't mean that its price will be the same. They also look at how big the square footage is. So like, they'll say even apartments. When I lived in my apartment was cheaper than another one because I had less square footage. And they said, oh, well, it costs this many dollars per square foot. That's one way we use it.
Kind of going off of that. Like how much money is paid from rent?
It might come down to how much we're paying on certain things. Here's what I want us to look at. Gentlemen, this is like twice I'm stopping for you. Next time I'm going to be marking you down. Please pay attention. Alright, so let's look at our notes, example 1. Our notes are not going to take us too much time because we're going to be crossing a lot of the examples out because we're going to do hands-on activity instead. But example 1 is how we find a unit rate. It says, you make fruit juice by adding 4 pints of water for every 2 cups of concentrate. Well, there's my ratio right away. 4 pints of water for every. That's the same thing as saying per, and that's the same thing as saying I have a ratio. So it is 4 to 2. Water to concentrate. Now I want to know how much a unit rate is. I want to know how much water do I put per cup of concentrate. Well, if I made a ratio table, I know that, hey, I want to make it 1. 2 to 1, I divided by 2. So I have to do 4 divided by 2. And I get 2. So the unit rate is 2 pints of water per cup of concentrate. This is my answer. Notice I don't technically even have to say 2 to 1. When you tell me you have a unit rate and it's 2 pints of water per cup of concentrate, it is understood that we're saying 1 cup. Alright? Now, I'm going to show, even though this is talking about something else, it's okay. We're going to show, instead of making the table diagram, we could have done this. We have the ratio 4 to 2. And I have to say, what did I want to know? My answer, I want to know pints of water per, I'm switching colors to try to help you guys see this, cup of concentrate. I will focus. I don't think that's the same concentrate. I'm pretty sure. Actually, I know. I'm not like, ooh, I don't think it is. You're like, my brother teacher's stupid. No, I know. So. Alright. When I have this, instead of making the ratio table, I could have easily just said, okay, pints of water, I have 4. I don't need a calculator for this, but it'll help you see it. I have 4 pints of water per. Per is telling me I'm going to divide by. Cups of concentrate. I had 2, so divide by 2. You did 3. Okay, 2. So that tells me my answer is 2 pints of water per concentrate. Alright, we're going to try this. Alright, we'll do this part together. Turn on the back side of your page. Yep, where it's completely... Actually, you have room to do it on the try it. You have room to do it on the try it. I'll take it back. Let's go to this try it. Just draw a line through your question. Okay, here's your activity. You're going to work in a table group. I'm going to give you a little bit of time. We'll see if you can get the answer right. This is a real life example. With one exception, because Peanut made me take a picture of him too. So, I took the Brothers of Destructions to Hy-Vee with me the other day. We had to get some cereal. We all know Captain Crunch is where it's at. peanut butter Captain Crunch is one of the best, even though I hardly ever get it. But I love it. So I took Eli and Bennett with me, and Peanut, too. And Eli grabbed his box of cereal. I want this one. And Bennett's like, I want this one. It's like the three little bears. This one's too big. This one's too small. This one's just right. Except when you see Jude's wasn't just right. So I decided every time, I swear to you, I'm not even making this up. I know I made a lot of the other stories up, but I'll tell you this part is true. Anytime I buy cereal, you'll notice there's like a family-sized box and a smaller box. Swear to you, every single time, I do unit rate. Every single time I shop. Which one is the better buy? And here's why. Here's the picture. Alright. Bennett grabbed Bennett, when I took the picture, he got mad at me because I ripped these off the shelf so I could take the picture. He's like, you can't do that. Put it back. It's like, oh. Hey, here's Bennett's box. Bennett bought a small box, or didn't buy it, but he wanted the small box. You can't see on it, but it was 12.5 ounces. That's what a regular box is usually around. So it was 12.5 ounces, and it cost $2.79. Well, Eli's was 17.1 ounces, and it cost $3.39. So Eli was saying, we need to buy mine. Mine's bigger. We have more cereal in it. Bennett was saying, we need to buy mine. Mine costs less. Well, I don't even know who was correct. So I was going to buy it between the two. And then, of course, Peanut wanted in the mix. So we had to grab the generic brand Multi-Meal that comes in a big bag. So I'm going to have you figure his out, too. Look how big that thing is compared to him. So, Multi-Meal's Colossal Berry Crunch. Not going to lie, that's pretty much the one we did buy, and that's the one we always buy. I love Colossal Crunch. It's 34.5 ounces at $4.99. Here's what I want you to do in your table group. Because I'm going to call someone for each cereal, and I need to know, this is what I'm going to write on the board, I need to know the cost per ounce. Because right now, the cereals are not comparable. 12.5 ounces, 17.1, 34.5. Could I use some number sense to figure out the better buy? Yes. Or, I swear to you, I do this every single time, I always find the cost per ounce. So, how much does 1 ounce of cereal cost? Remember how we looked at doing this. When I call on you, if you knew how to solve it, you're going to earn the sucker. If you did not know how to set up the equation for one of these, talk to someone in the classroom. Because if they help you, they get the sucker, and you do as well. Okay? About 2 minutes to work on this. Go. All right, I'm going to help you on this first one because there's still some confusion. So, remember, the most important thing is I want to know cost per ounce. Now, per is going to be our hint that we are going to be dividing. So if I want to solve this, what was the cost of Bennett's cereal? How much did his cereal cost?
$2.79.
Okay. So his cost $2.79. This is why it's so important to listen to what we're asking. Cost per ounce. $2.79 per how many ounces?
12.5.
This is my equation now. If we write the ratio out the way they ask us, we have the division problem. So on the very first one, 2.79 divided by, so I did my cost, and I'm dividing it by how many ounces I have. This would round to,
22
good, because the 3 is less than 5, so we round down. So my answer is, Bennett's cereal costs 22 cents per ounce. Okay? I'm going to pause and give you about another minute. I need you to do Eli's, and then I need you to do Jude's. Alright, for Eli's, who can go ahead and walk me through this? We'll see if you get the sucker. Side?
Well, it's $3.39.
Okay, so my cost comes first. His was $3.39
For every 17.1
per. Means divide and 17.1 ounces, what you said.
Yeah.
So there's my division problem. We write the ratio based off what we ask. Cost per ounce. Cost per ounce. And what did you get, Si, before I did mine?
I got 19 cents for every 1 ounce.
Okay, let's see if he's right. Very close to right. I'll give you credit for it.
20.
Should be 20 because 0.19, the 8 tells me we round up. So it becomes 20 cents per ounce. I will give you credit for it though. One last one. Peanut, who had to throw the whole thing off. Alright, who's the other side? Ooh, good catching. Ooh, like ninja. Alright, Eliza, what do we do? Cost per ounce. So what am I going to do?
I did $4.09
Good. His cost?
divided by 34.5,
34.5 is my ounces.
and I got 14 cents
Okay,
per
let's
ounce.
check. Hey, get over here. Alright, so 4.99 divided by 34.5. 14, there's a 4, rounds down, so 14 cents. Alright, Liza is correct. Now, new question. So, actually, before I move forward, anyone have a question on how we do this? Alright. Who cereal should I buy? Just based on price. Nothing else in consideration. Just based off price, whose cereal should I have bought? Bennett, Eli, or Jude? Trevor?
The last one.
Jude. His is only 14 cents per ounce. His was the most expensive, but I get more cereal for it and my price is better. Now, full disclosure, it's also because it is a generic brand. Doesn't taste the same. It's a little bit different. So, between the two Captain Crunches, who had the better buy of the Captain's Peanut Butter Crunch? Eli or Bennett? Bennett's the first one, Eli's the second one. Joseph?
The second.
Eli. 20 cents per ounce. Not by much, but his is just a little bit better buy. So yeah, he has more cereal and it costs more, but he saves a little more too. Alright, so if you're understanding this, it's very simple what we're doing today, once you get a hold of it. If I'm asking you, I want to know how many miles per hour. If you want to write this down in your notes, you can. If I ask you how many miles per hour I drive, and I said, ooh, I know. I'm going to round it to make it easy. This weekend, Sunday, yesterday, I took Bennett to meet my in-laws, my mom and dad, in Seneca. Because Bennett went home, he spent the week with them. So, I took Bennett home. It took me 2 hours to get to Seneca. Actually, I think it was an hour and 45. But we'll pretend 2 hours to make this easy. So it took me 2 hours to get there. And I'm going to tell you I drove, let's say I went, from here to Seneca. Let's get an exact answer here. Give me 1 second. Google Maps. Should be in my recent Seneca. It is, hey, what happened here? Okay, I see how long it should take me. I don't know how many miles. Start. Oh, come on. It tells me all this, but it won't tell me miles. It keeps telling me how. Oh, there it is. Okay. Say it's 112 miles. Okay, if it's 112 miles and it took me 2 hours, it did, but we'll pretend. What was my average speed? How many miles per hour did I drive? Now, really, guys, all we have to do is fill in the blanks. So, Cohen, the first blank is miles. How many miles did I drive?
112.
So you would write 112 per means I am dividing. Avery, last one is I want to know hours. How many hours did I drive? 2. What is my answer? Miles per hour. Siri? Use your calculator. What'd you get? Try it one more time. $112 divided by 2, 56 miles per hour. All right. I want to finish up here real quick. So, go ahead and be on your notes for example 2. We're going to do this one in just a second after this next activity. Here's your next group activity. Do not touch them yet, but I put at your desk, you're able to use the calculator. I'm going to give us about 3 minutes to do this activity. You are going to have a picture when you grab yours. This one says Cheerios, 9 ounces for $2.50. What you must do, and I don't want you to write on these because I'm going to want them back, you have to go find someone that has the picture that matches, but it's a different quantity. So this one's 9 ounces for $2.50. This one's 20 ounces for $3.79. Using your calculator, you want to find out what your unit price is. So for everyone, we're going to do our cost divided by however many we have. So, Char has that one. Find the unit price. I have 20 ounces at $3.79. 3.79 cost per ounce. 20 ounces. Mine is going to cost about 19 cents. What is yours? She's typing, I'm looking over, so she typed in 250. No, she put 0.250. She failed that line. That's all Queen and laugh at her. Yep. So she put 2.50 divided by 9, and she got 0.28. 28 cents. Who wins?
You.
Wow, I won by a lot, actually.
Yeah.
So, when you're done, you and your partner come up to me, tell me who has the better buy, and then I'm going to write your name real quick on the board, and you get a point. If the class is behaving and not getting loud, and everyone's focusing, whoever has the most points at the end of 3 minutes wins the sucker or something, or a donut. Okay? So, if you can't find anyone, you can come up and get a new picture card. When you and your partner's done, you come over, you put your card face down, and you grab another new one. Okay? 3 minutes, ready, go. Okay, good job. Overall, It looks like in and side tied at 3 points, so I'll give them something.
Wait,
Um,
let them get two, and then see them.
But anyways, hopefully you guys did pretty like. As long as I think some people just kind of did this. People are taking it serious. I think you were getting something out of it. Learning how to do unit price is so important. When you go to the grocery store next time, make sure you're looking at this with your parents. Try and help them save money because I've even seen it once before where I've done this. My biggest example is chicken and a biscuit. They have the small box and then they have a giant box. And most times I think it was like the giant box is about twice as big. So I do the unit price and I'm like, wait a minute. The small box was like 10 cents an ounce, and the big box is 45 cents an ounce. Well, wait a minute. If I doubled it, it's 20 cents an ounce compared to 45 cents. I'm like, I'll just buy 2 small boxes and I get the same amount, but it costs me less. Just because it's more, and you say, well, I'm really hungry, so I need more, or I'm feeding more people. I've seen this at the grocery store all the time where you can buy 5 pounds of meat, the logs, or you can buy 1 pound. And sometimes the 1 pound, it's a lot cheaper. If you find out how much it costs per pound, I find out like, hey, I could buy this for $2.50 for 1 pound, or $15 for 5 pounds. Well, $2.50 times 5 is only like $12.50. I'd save $2.50. To be real with you, you're going to see an example that I took the picture of. You save a lot more than that if you would have done the unit price. So, start looking at that with you. Okay, we got to continue going because I have one more activity for us to do and 1 to 2 examples left. So, look at example 2. Using the unit rate to solve a problem. So it says a piece of space junk travels 5 miles every 6 seconds. Well, there's our ratio. 5 miles every is my per, and then we have 6 seconds. So here's 6, here's 5. It's very easy to throw things in a ratio table. It helps us visually see them. So distance, time. How far does the space junk travel in 30 seconds? Okay, there's 2 ways to solve this. I'm going to show you both of them. And the reason I want to show this is because on your homework today, you are going to have a fraction. Do not flip out. I'll show you why. Now, the first is we made a ratio table 5 to 6, and I want to get to my unit rate first. This is how we can use a unit rate to solve other things. If I said 5 to 6, I want to get to a unit rate of time of 1. So 6 divided by 6 is 1. So I have to do 5 divided by 6. Now, on your homework today, you're going to have a problem like this. If I do my division, it comes out to a decimal that's repeating or never ends. If that happens, write it as a fraction. 5 divided by 6 is the same thing as saying 5 over 6. Remember, that's what a fraction means. Numerator divided by denominator. So they did 5 divided by 6 is 5 6. 1 to 30, I do 1 times 30. So when I do 5 6 times 30, that's just right here. Do a fraction, I about wrote 31. And I would have 5 times 30 is 150. And it's all over 6. What did I do wrong?
Did you just add the 5 and the 6 up for the beginning?
Oh, it's because I'm still a fraction. I'm like, what in the world? Okay, so now I have 5 times 30 is 150. And then can 150 be divided by 6? Can I simplify? Yeah, it breaks down to 25. 6 goes to 150 25 times. That gives me my whole number. So this tells me in 30 seconds, I will go 25 miles. So I'm going to change this one. Right here on this blank, cross this off. You can use this one. We're going to use this blank. I want to write down 5 to 6. This middle one, I'm going to tell you right now, is going to be your unit rate. And I want to know how far are we going to travel in... I think I did this the other day. I think I said 27 seconds. So, how do I want to do this? I want to make sure I do the same as last time.
99.
Because now I can't remember. Give me a second. Don't cheat. Don't look. Oh, I did say 27 seconds. All right. So in 27 seconds. Oh, I see something, by the way. We about failed at life. 27 seconds. Look, they flipped these because this was asking something different. Always pay attention to your labels. Okay, I want the same one. This is going to be miles. This is time in seconds. I started right. Time and seconds at the same time. Time. All right, I want to know in 27 seconds. So, NASA called me and go, Sissel, we know you're smart. Much smarter than NASA engineers. So we're going to spend the time or Earth's going to die. We're going to call you real quick to explain the situation where every second matters. So, as we keep talking, we're wasting time, but I'm going to explain it to you. Now, we have an asteroid coming towards you. It travels 5 miles every 6 seconds. And how far will it go in 27 seconds? Because we're calling you collecting my battery is almost dead on my cell phone. We have 20 seconds left. We need no distance. Okay. This ain't going to make sense, but that's what we're doing. Okay, that's why. How far would the asteroid radius? It's like, whatever, dude. Alright, how far is it going to travel in 27 seconds? How do we find this answer? Now, the reason I switched it to 27 seconds, if anyone's wondering, if you look at the first example, did I really need to find the unit price or the unit rate? Couldn't I have just done 6 times 5 and got to 30? 5 times 5 was 25. Yeah. I want us to find a unit price. Unit rate. I keep saying price. Unit rate. So we do the same thing. I need the unit rate. I need 1. I need to know how far will this thing travel every single second. We divided by 6. So I'm going to do 5 divided by 6. And we already found out that's going to be a fraction because there's an n. Now think about this fraction. It's fine. It makes sense. It says every second it will go 5/6 of a mile. Will it travel a full mile? No, it doesn't go a full mile. So it's going part of a mile. How do I find the answer now? If I said I want to know in 27 seconds. Sai?
Oh, so 1 times 27 is 27. So you would do 5, 6 times 27.
Good. 1 times by 27. Don't flip out because you'll do this on your homework today. So I'll do 5/6 times 27. The fraction of 27 is 27 over 1. If I multiply, is that right? 135? Okay. Now, can this simplify?
Yeah.
Okay.
It can turn into an improper fraction.
Okay, so what's 135 divided by 6?
22.5.
Oh, that was pretty easy. So, my answer is this space chunk, this asteroid, whatever it is traveling 22.5 miles per 27 seconds. But it's per 27 seconds. Probably shouldn't have put the P. I should have just done it this way. Miles per 27 seconds. So in 27 seconds, this thing would have went 22.5 miles. Could I continue to use this information? What if I said, I need to know how far that thing's going to travel in 1 hour? Could I do that?
Yeah.
We'd first find out how many seconds are in a minute, how many minutes are in an hour. So 60 times 60 is 3,600. We would have times everything by 3,600. So we continue to work on this. All right. Let's look at self-assessments there if you want extra practice. Real life example. I'm only going to look at this quick. You're going to fill out notes because you have a different real life example you're about to do. This real life example, the only thing, I'll do it kind of quick for you. I'm not going to have you do it because your activity is right before your homework. You buy 2 pounds of salmon fillet. Now, this is one way to do this. They keep using ratio tables. And we can do that, but we can break it down really, really easy, and I'll show you something. I buy 2 pounds of salmon fillets at store A for $21.50. Now, I'm going to want to know cost per ounce. Usually, if you're figuring anything, you always put your cost first. Right now, when I travel, when I bought my pickups don't get very good gas mileage. How many miles per gallon? And when I find this out and I have to figure it used to be, your cars now will tell you. When I was growing up, my dad, we had a notebook, and we lived on a farm, and anytime I filled up my truck or my car or the tractor or anything, the tractor was different. You had to go by per hours, not miles. But, that's for another story. He made us keep track of what was our gas mileage. One reason is it told us if, well, he didn't like it, but he found out if I was hot rodding with my pickup, because if I was paying around the gas, I was hitting and peeling out, which I did not do growing up. And I was messing around with the truck, it burned gas faster. So I always had to write down, when I filled up, because we had a big 500-gallon tank on the farm, when I filled up, I always had to write down how many miles are now on my odometer. We reset every time you have your main odometer, you have your trip odometer. The trip one, every time I filled up, I had to reset it to 0. So I had to write down, how many miles have I driven? How many gallons of gas did I just put in? And it would tell me, I divide the two. Miles divided by how many gallons I put in, told me how many miles per gallon did I get this time. And when it was like, one time it was like 9 or something. When it was supposed to be getting like 17. I might have gotten in some trouble. He figured out I was not playing with his pickup. Anyway, another story. 2 pounds of salmon fillets at store A for $21.50. This is what you're going to write. $21.50 per 2 pounds. I could make a ratio table. Or, right here what we just did at the board. Cost per ounce. Where's my calculator?
Right here.
Okay, $21.50. That's my cost. Divided by how many ounces I had. How much does 1 ounce of salmon cost? Okay, so I would say $10.75 is what 1 ounce cost at store A. For store B, now $33.75 for 3 pounds. 33.75 divided by 3 pounds. $11.25 for 1 ounce. Which, now it says, how much less would you spend? Cool. We're going to find that in a second. Which one's a better buy?
Store A.
Store A. Is that what my question asked me?
No.
How much less would I spend for 5 pounds? So on each one of these, I need to get to 5 pounds. To 5 pounds. Well, if it's $11.25 for 1 pound, times 5 is $56.25. $10.75 times 5, $53.75. We then have to compare the two. 56.25 minus 53.75. $2.50. Now, does that sound like a whole lot? Really? But if you're budgeting, and this was just one item I bought, and I did that with 2 or 3 items, maybe I saved $5, $6 on this one trip to the store. And then I sent another $2, $3 to the next trip. $2, $3 the next time. After about 4 or 5 times, I'm saving $20. Maybe more. If it's 5 trips, I could be saving just a little over $10. So we do this in real life because it saves us money. This is the math that is not just, hey, we have to learn it because we're in school. I'm being honest with you. This will help you save money. So this is why you should always use unit rates. Okay, here's your last assignment. Your homework is going to be there's 10 questions. It's online. It's due after Thanksgiving break.
Didn't we get our homework cut in half?
Ooh, did you guys?
Yeah.
Okay, we'll write it down here in just a second. I did it for another class too. All right, before we go, I want us to try this assignment. So, flip your papers to the back, your notes. At the top of it, write Sissel's Supper. It's actually Sissel's Super Supper. You know what? I don't think we're gonna have time to do this. Okay, let me ask you guys this. We can do this one of 2 ways, and I'll totally let it all up to your class. We can either, 1, work on this project right now to see if you guys are understanding, or 2, I can let you start your homework. If I let you do your homework right now, yeah, let's just do that either way. And then on Monday, what I'll do, if you don't finish your homework, it will not be late yet. On Monday, when you guys come to me, we'll finish reviewing, and I'll give us about 10 minutes to finish up our homework. But if you can't finish homework, you can. All right, quickly, everyone grab a blank piece of paper.